So first of all, thanks everybody for being here. There's actually more people than I thought, because when talking about textile-based interactions in JavaScript, it's always a bit something, like it's not something that you're going to go back to work with and say, that's it, I quit my job, I'm just going to do textile interactions. So I'm actually surprised with the amount of people that's here today, so thank you so much. Before diving into the topic of textile interactions, I thought I would give a little bit of context. So let's say it all started 5 years ago when I started using JavaScript to do things outside of the browser. And my first experiment was to control a sphere or robotic ball with the movement of my hands over a leap motion. The leap motion is this device that you plug on your computer, and it detects the movement of your hands, and I was able to kind of like move around and control the movements of this ball. And as I said, it was the first time that I was using JavaScript outside of the browser, and this is where I started playing around with all different kinds of human-computer interaction. Then I moved on to things like using conductive ink on a canvas to trigger projection mapping, and it was just another way of using touch, not at all using any keyboard or any phone to trigger stuff. But then instead of just the body, I tried to use Arduino and hardware to trigger things without something else than my body. So I'm just hiding the light here, but it's basically using the flashlight from your phone to trigger light sensors that trigger other lights that trigger light sensors, like a chain reaction. My goal for this was to recreate an installation that I saw, but all of this was actually done in JavaScript. And then I also moved on in interactions with the browser using machine learning and head motions. So I was really interested to see if I could use motion recognition and machine learning to allow people to communicate without the movement of their head. So again, no keyboard and no phone, just being able to really quickly train a machine learning algorithm and have different kinds of interaction. That type of experiments also led me to play around with brain-computer interfaces, where I was able to interact with the browser using brain sensor and thoughts all in JavaScript. And more recently, and a bit more fun, I kind of transformed my living room into an immersive game using the Web Bluetooth API and JavaScript, where I attached my phone to a normal skateboard, and using the accelerometer and the gyroscope, being able to kind of like, I just moved around on a real skateboard and was able to actually play around with a game. And the purpose of that particular example was to be able to use things that are available for everybody and just transform that into something a lot more fun than just a website. So my name is Charlie Gerard. I'm a developer at Atlassian. I live in Sydney, Australia. What I do during the day is not at all this. I just, work on a product that you might be using. I just started last week. The product I work on is Jira. I don't know if you know. Yay! All right. I mean, some people hate it, some people love it. So, don't even talk to me about it. But I just started. It's pretty cool at the moment. But outside of my job, I'm also a Google developer expert for web technologies and the Mozilla tech speaker. So these two programs in the community actually are groups of people who like to share knowledge online through blog posts or conferences, and you have access to kind of like some exclusive news from Google and Mozilla, and you're supported in sharing knowledge in the community. So if you're interested in these programs, you can actually apply online. It's open to everybody. But most of all, as I said before, I love experimenting with human-computer interaction. I really believe that the keyboard and the phone is kind of like a very restrictive way of playing with technology, and I'm really excited about the things that we could be doing, but for some reason, we're still kind of like using the keyboard. But today, I'm going to talk about textile interfaces. If you've never looked into this, maybe that doesn't really make sense, so I'm going to talk about an example. So usually, a lot of the time, let's start with the definition first, but it's basically using textile, so the stuff that you wear, or textile all around us, to interact with interfaces and devices. So an example of that is usually wearables are seen as the output of the interaction. So you might have seen this example, but it was in 2016 for an advertising campaign for Vodafone, I think, where the goal was to create a jacket for cyclists that would help in terms of safety. So the jacket would connect to Google Maps on your phone, and it would have LEDs at the back that would reflect the direction that you're about to take, so that the drivers behind you would be aware of your direction and hopefully not run over you. But this is an example of, there's a few examples out there where the wearable is actually embedded with LEDs and it becomes the output. But what I'm interested in is using wearables as an input. So I'm going to, hopefully the sound will work. It is Project Jacquard. I don't know if you've heard of it, so I'm just going to play the video. It's only a minute and a half, if it loads. Yes.
Call from unknown. Getting next direction. Turn left onto 15th Avenue. Text from Emily. I'm running late, see you at the shop. You are 5 minutes away and will reach your destination by 7:05 a.m.
So basically, you can see in this video that the jacket is the way to interact with the phone rather than the other way around. And you can control things like hanging up a phone call or changing music or get your next direction. And I'm talking about this one especially because it's been the main inspiration for what I've been working on and for this particular talk. So why am I talking about this? So I know that, as I said, it's not something that you're probably going to go home and do, but I think that it's still important for a few reasons. Interactions are evolving, even if it's not there right now. We can see that, for example, voice UIs, like you might have a Google Home or an Amazon Alexa, so we are starting to actually communicate with devices using our voice. Maybe at the moment, people are not really using them because maybe you think that they're not that performant. I don't know if you've been following Google I/O, but Google Assistant is becoming actually quite impressive. If you have not watched the videos from Google I/O, you should really check it out. The demo about Google Assistant is pretty impressive. But it's not only voice UIs. For example, at the airport, more and more they are avoiding your contact with people, and you have passport checks with face recognition. So you're not really interacting with people anymore. It allows you to go a lot faster. And even in China, sometimes you can pay with your face as well. So facial recognition is being used more and more as a way of interacting with technologies. So maybe textile interactions are not there or are not that evolved right now, but I do believe that there is a lot of potential and it's coming. And yes, so there are exciting possibilities. I put together a few examples in this talk that I'll talk about right after. And I think there's even more possibilities than I thought of when I started working on that talk. But after doing quite a lot of research, I realized that there's applications for it in so many different domains. And then finally, it's important to me because I like to demystify some stuff that you can see. So Project Jacquard, I came across it maybe 3 years ago. And my first reaction was like, how does that even work? Like, I don't understand. It seems so complicated and stuff. And then after spending some time thinking about it and reverse engineering the way they did it, I realized that it is possible, and it is possible by a lot of people. You don't have to have millions of dollars. You don't have to have a team of researchers or a PhD or whatever. There is actually material that is available to a lot of people, not too expensive, and it's all about reverse engineering the way it would work, and actually there's information online all around. So I'll show you a bit later what I did and how to build it. So how does it actually work? So we saw in the example that you can interact with textile, but yes, how can you actually do that? And it's just kind of as simple as this. And what this is conductive thread. So if you think about normal thread that is, in your clothes, basically it is thread that is mixed with stainless steel strands, and stainless steel is conductive. So mixing the thread with stainless steel makes the thread conductive. And what is really cool about this is that as it is conductive, you can use it to create circuits. So an example of that is this illustration, where instead of wiring components together with wires that are not always that flexible, you can actually wire everything together with thread, which makes everything really flexible and something that you can actually wear. So in this example, you have 3 different LEDs connected to a power module. And all of this can actually, yes, use threading between the components to create the same kind of circuit that would be created with just wires. But it's not the only thing that's important about this concept. It's also the fact that the concept of electrical conductivity. So this diagram or like picture describes more the way capacitive screens work. I couldn't really find one that was about textile, but it's the same concept. So when you think about a circuit where everything is assembled with conductive thread, there is current going into that circuit. And as the body is conductive, when you touch the thread, there is like a really, really small electric charge going through your body to complete the circuit, so you don't feel it because it's really small. It's not the same way as if you were putting your fingers in a PowerPoint. Don't do that, of course, but it kind of works the same way. It's like the electricity does go through your body to complete the circuit, and what it means is that if you read the current that goes through certain pins, when you touch the conductive thread, you actually have a drop of voltage in the current that goes through. So it means that you can track that. You can know the difference between am I touching the thread or am I not touching the thread. And as soon as you can see this difference between touched or not touched, then you can use that data to make something interactive, like anything that you want. So different applications. So this is where you can see that it has potential in a lot of different fields. So first of all, augmented furniture. I'm really excited about this one because I feel like my house could be a lot more exciting. So this particular example was called the emotive couch. It's developed by a team of researchers. So it's not something that you can buy. But I think the concept was to be able to understand the emotion of the user based on how they touch the couch. So if you move like you're annoyed, then it would dim certain lights to calm you down. Or if it feels like you're laying down on the couch, then it would maybe turn off the light because you're about to sleep or whatever. So if I wanted to embed my couch with stuff, that wouldn't really be what I want to do. What I'm more excited about is to eventually use my couch as a remote control. So instead of having a remote control, I would just be able to like touch the side of my couch and turn my TV on or off, or switch channel, or put the volume up, down, turn on my lights, whatever. And all of this is already possible. And it means that yes, you would waste less plastic because you wouldn't have a remote, and it would be in the couch. And I think that's pretty cool. So that's just one example. Then there's also accessories for your house as well, but this is already available actually. This speaker is a kind of like tangible, texture interface. I think I'm going to show you the video quickly because it explains it. Woo, this is really small. Explains it a lot better. Whoops. Yeah, that should be all right. I'm not going to play the whole thing, but you'll see what I mean. So I'm just going to pause there, but as you can see, you can just touch the textile on the speaker, and you have different types of interactions. And the fact that this is available and the fact that you can buy it online is pretty cool. I'm not only just talking about research projects, there are real products out there. Next, some musical instruments. I don't know if you've heard of Imogen Heap. I'm just going to show a really small part of this video where she makes drums at some point, and I think that's pretty cool.
More effects, and when I come closer it's kind of more intimate and quieter, and there's not so many effects. And so, for instance, I could walk into this area of the stage and kind of do a kind of drum action, and then you would hear drums. Yeah? Nice. I've got...
All right, I'm going to stop there. If you want to watch the entire talk, there's more to it. But basically, there are sensors in her gloves, different types of sensors, flex sensors, or rotation accelerometer and stuff like that. It's all put together in the fabric, and you're able to create a new type of musical instrument. So we can think about music a different way than we have before. It's like your body becomes the musical instrument. So if you're into music, I think there's quite a lot of potential out there. And the gloves that, in this video, that was quite a few years ago, and it was just a prototype, but I think that now it's actually going to become available to buy. This photo is like really pixelated and horrible, but I couldn't find something that would illustrate better what I'm talking about. But in terms of health monitoring, you could use clothes for newborns to detect the way they're moving. So for example, when they sleep, you would know if they're sleeping on their back or on their tummy or whatever. You could have clothes embedded with heart sensors to make sure you could track their health over time. And I'm talking about newborns, but I'm sure that it could help also other people. And yes, this is where you could see also the potential in terms of health. Remote communication. So this one is not my favorite, but it's there, so I wanted to talk about it. It's called the hug shirt, where you have different sensors all around the body. I think it was made at the beginning for remote, long distance relationships, where you could send a hug to your partner or things like that. I see more potential in the relationship between a doctor and a patient that's remote. So maybe in London you might not think about it, but in Australia you have a lot of people living very far from any city or any hospital. And if you actually had the chance to be able to communicate with your doctor and tell them exactly where it hurts or how much it hurts, you could actually have maybe or eventually a better diagnostic of what is wrong. So that could help in that way. This one, accessibility, you might have seen it as well. That's a really cool example. So I'm also just going to show the video instead of, it's just a minute and a half as well.
Hello. My name is Thomas. And this is Navid. We are inventors in the Lemelson MIT Student Prize Competition.
So yeah, I'm probably not going to show because I probably need to move on. But you can watch it later if you want. I think you understood the concept. It's sensors embedded in gloves as well. I think it could probably work the same as the gloves for a musical instrument, where you use the flex of the fingers and the movements, and you probably get all that data, you feed it to a machine learning algorithm, and you're able to recognize or to translate movements into words and being able to communicate with people. This one is not conductive thread, but it's a really cool type of textile where it changes based on the amount of pollution in the air. So the color changes. It's textile, and you add a certain chemical onto it. And in terms of being able to understand your own environment and make conscious choices, I think it's pretty cool that you become more informed about your environment. And instead of just walking around the city and not knowing what you actually breathe, you could actually see it on your clothes. Maybe you don't want to, but at least you'll be able to make better decisions about the type of air that you breathe and things like that. And finally, final example I'm going to show, that's a bit more extreme. It's around human body augmentation, where I don't know if you've seen this talk. There's a project called Neosensory, where it's a jacket embedded with vibration sensors to understand your environment, where the speaker in that talk was actually pulling tweets from Twitter and trying to get the emotion of the tweets, and he was sensing on his jacket if the audience was happy or sad or angry. And it's like a way to add senses to people. So that seems a bit extreme, but when you think about it, some of you might have smartwatches, and it vibrates when you get a call, or when you get a text, or when you get an email, and you might not realize it, but it vibrates differently depending on what the kind of notification that you get. So in a way, we have already started training ourselves to understand vibrations, or adding a certain kind of sense to our body. But anyway, so I'm going to talk about what I've been building, because now that we saw these stuff that are pretty cool, mine are actually not that cool, but still I got somewhere. So the first prototype that I built was based on one of the early prototypes of Project Jacquard, where I think it was kind of showcased at a conference where people could interact with the fabric and see a visualization. So I was quite intrigued by this particular example because I really didn't know how they would get the right X and Y axis and stuff like that. But after working on it, I kind of made my own that looks like this. So it doesn't look as good, but it kind of works the same way. So on the right, my hand is on a piece of fabric with conductive thread. And on the computer is a browser, and that has just some 3D using the 3GS framework. So there was quite a few limits with that one. So that was really my first one. So the thing is kind of like there's shiny front end, and in the background it looks like this. So it was really horrible because it's obviously there's cables everywhere. It's not portable. It was really my first thing, and I just wanted to be able to validate the concept. Is it possible with almost no resource? So there was a few limits with that. So obviously, portability was really bad because, well, I had cables everywhere, and there was no way I would have been able to travel with this. There was a problem in terms of connectivity because I used an Arduino Uno that had to be plugged in to the computer to be able to upload the sketch and things like that. So I didn't have any Bluetooth or Wi-Fi. And latency, because I was using the Arduino, I actually was sending the data from Arduino to a node server and then using WebSockets to the browser. Like, it was horrible. Like, it was going through so many layers that there was a bit of latency between the touch and the response on the screen. So then I moved on to my second prototype that I did bring with me. And my main change is that I changed the board. I changed from an Arduino to an ESP32, which is Arduino compatible, so you can still run Arduino sketches. But it was better. It kind of fixed my problems because it has Bluetooth, so you can communicate via Bluetooth. And also, some of the pins from the board have kind of like a touch sensitivity already. So you can track the capacity, like it's capacitive touch, without having to write your own program. So they have, using the ESP32, they have a function called touch read that gives you the amount of capacitance without you having to write anything more. So yeah, that was a main change that really helped me. So in terms of, kind of like high-level architecture, you have the fabric on the left with the conductive thread connected to different pins of the ESP32. I have a really small Arduino sketch that I upload onto it, and then you kind of broadcast as a Bluetooth device. And that can be picked up by any other device. It can be a computer, a phone, a light bulb, a speaker, or whatever. And all of this can be done in JavaScript because of the Web Bluetooth API. So you can connect directly to the browser, no need for a Node.js server anymore. And I'll show that a bit later. So in the end, it looks like this. So there's I kept the embroidery hoop around because it was easier to transport, but usually you would remove it. But it looks, so the wires connected to the board are actually not necessary. You could kind of link the thread straight away to the pins. The issue I had is that my needle was too big to go through the pins, so I had to actually switch that to use cables instead. But I would have loved to actually not have to use cables because then the amount of material I need would have been a lot smaller. So if you think about a before and after, that's kind of like a lot better. It's just my second prototype, so it could be even better later. I could find like a smaller board or make it better. But this is it fixed all my issues. It is all of a sudden portable. There is connectivity via Bluetooth, and there is a lot of less latency because I just connect straight away to the browser. So let's talk a little bit about demos. I put together a few things. I don't know if you have noticed, but you have been in a live demo for the last 22 minutes because I have barely touched my computer. I've actually been switching my slides with a piece of fabric that I brought with me. So basically, I switch slide and magic! I touch a piece of fabric and it just switches my slides. So that's kind of like my first demo. What I really wanted to do is embed it in my clothes. But I wanted to switch my slide with my pants. That would have been more fun. But for a lot of reasons, I wasn't able to do that. I didn't really have the time, and I thought I would do it on the way here. But you can't bring scissors or anything on the plane. So obviously, I didn't. So I brought what I had. And I wanted to say something else, I totally forgot. Yeah, so at the moment, it is connected to my computer just because, same on the plane, you can't bring with you certain type of batteries, and the batteries that I had at home to connect to that were the type of ones that could explode in planes. So obviously, I didn't bring them. So it is connected to my computer just to have some power, but usually it would be totally portable. I could be over there and switching my slides, and it wouldn't really matter. But the second demo that I put together is being able to control Spotify. So I put a video there because I'm not sure it's going to work. It's been a bit flaky, especially I tried to do it just before coming here, and for some reason it wasn't really working very well, so I have a backup video. But I'm going to try to exit it. And all right, I'm going to close that because I don't need it anymore. OK. Oh, I should have actually, my bad. I forgot that I need to upload this before. Don't look at my if statements; they're horrible. Let's look at this. Okay, so it's gonna take a minute. It's gonna take a minute to upload. So that's just a little bit annoying. I'll go through this piece of code a bit later. Unfortunately, I have to talk a little bit about Arduino because so far you can't do absolutely everything with JavaScript. If I had picked another board, Arduino, you can use Johnny 5 with Arduino. That allows you to do most of it in JavaScript. But for some reason, I tried an Arduino Wi-Fi board, and it just wasn't working with what I wanted to do, so I had to move on to the ESP. If it wants to upload, it's almost there. Come on. It will do it, but I don't know why it's taking so long. At least it's not failing, so that's better than nothing. But no, not yet. Okay, done uploading. Cool. All right, so I'm gonna put that here. Hello. All right, I was listening to Queen just before coming here, so you're gonna have some Queen. But if I turn on my server, and let's play this one, so I can hopefully. Or put the sound up or down. I can switch song. I don't know if I'm coming back to the... Oh, I'm moving on to the next album. Yay! I'm going to put it up. So that's it, basically. So yeah, so what you have to imagine... I'm going to stop it there because you got the concept. So of course right now it doesn't look like, okay, right, I'm doing it as a demo, but in my house I wanted to try and do it on my couch. So of course this is what I brought with me, so it's not embedded in my couch, but it works, and that's what I would have liked to do in the end, is being able to just sit there and be like, ding, ding, and be super lazy, and just do stuff. So you can embed it with Spotify, but you can do whatever thing that is connected to the Bluetooth or the internet can be controlled. So let's talk about code samples. Let's say that you just want to track if one pin is conductive, or the amount of capacitance that goes through one pin. So in Arduino, if you've never worked with it before, you have a setup function and a loop function. The setup is just what runs once when you flash the board, and loop is what will run over and over again. So what I'm just doing is opening serial communication on a certain port, and then in the loop function, I'm just checking that, if the touch on a certain pin is less than the threshold, it means I'm touching, and I'm just sending that to basically to my, let's say, terminal in Arduino, just to check that it's working fine. The thing is that this is just locally. I'm not sending the data to anywhere. So what we move on later is being able to send the data via Bluetooth. And if you don't understand all of this, it's fine, because it's actually coming from one of the examples that you can use out of the box. So you don't actually have that much to change. But basically, you just have to declare a few variables. You have to have UIDs for services and characteristics. If you actually don't know how the Bluetooth protocol works, it works with services and characteristics that you can subscribe to get data. Then in the setup function, we just give a name to our board. So I just called it my ESP32, but it can be anything that you want. Then you create a server. You create also a service that you add to this server, because this is what you're going to be able to actually get in the front end later. The characteristic, you just have to give it a few more parameters. You have to kind of say, do you want to read it, write it, notify it, indicate it, and things like that. Then you start the whole thing, and you start the advertising for the front end to be able to figure out that there's a device that it can connect to. So this is pretty standard. You will barely change any of this. It's in the loop function that you will change stuff, because you're saying, again, if the data that you get from that pin is less than the threshold, you just store it in an integer, set this value in the characteristic, and notify it so that the front end can have it. So this is, Arduino, but the cool thing is the fact that you can get it in the front end. So in the front end, you declare variables as well with the name and the services and characteristics ID, which are exactly the same as the Arduino code. And then using the Web Bluetooth API, you request that particular device. you connect to the device and you get, a promise back with the server and you ask for the primary service. Then you get the characteristic that we defined at the top. And in the end, when you manage to get that, you're going to start notifications so that every time the value changes from the Arduino, you're able to get that in a function, that I called handle notifications, but it could be anything. And in here, you actually get the data coming from the Arduino, and this is in this part that you can do whatever you want. So as soon as you touch, then you can trigger something on the screen or on Spotify or really whatever you want. So this is pretty cool that you can go from just Fabric to the browser. But there's, of course, a few limits. There's always limits. So it is partially waterproof. So if you, from the Google Jacquard, Project Jacquard project, they say that you could wash it a maximum of 10 times. So they added, I guess, a special coating on top of the fabric. I didn't do it with mine because I didn't really know what type of product I need. But usually you can actually add a certain spray on the thread to make it more waterproof. So it should be all right. But if you do something at home on a couch, I don't think you really care about the rain. It's more if you do a jacket, yes, you will care. Apparently, conductive thread works for 2 years maximum. So I think if you want it to be quite performant, it will work for 2 years, and I don't really know what happens after. Maybe it's just not really performant after that. But that's why if you're thinking about embedding that into things, instead of putting it straight away in my couch, I might just, just sew it on a patch and add that on my couch so I can change it every 2 years. The fragility part, I think, is more just my fault because I did everything by hand, and I think if I had a machine, it would have been more robust. This is where, you kind of start to see the difference between doing stuff at home and being Google. Google had like a team of like awesome stuff, and when I just had me. So it's fragile because I'm not very good at this neither. It was the first time I was doing that stuff, so that's probably why. But of course, I was really scared coming here that it would fall apart, but it didn't, so it's actually not that fragile. And the capacitance changes with external factors, and that's quite interesting because it means that depending on the level of humidity, your threshold is going to be different. So maybe here I would have to, adapt the threshold compared to Australia, because rain. But, it does depend. So if you do it at home, you probably would be fine. But if you do a jacket, you might have to change the threshold every day. I don't know, I haven't tried. But it's quite interesting. You have to keep that in mind. So what is next, though? Because there's always more things you can do. So I would really like to try to put it in a jacket because I feel like, so of course, Google built their own custom boards, and I would be really interested in doing that. Instead of being restricted by something like that I have to find online, I know that I could make my own, which would be really interesting. So that's like one of the things that I would like to try. There's other type of materials that would be really cool to play with. So you have a material that changes with the amount of UV light. So that would be, in Australia at least, that would be quite interesting to see if you could have a T-shirt that changes with the amount of light. Skin cancer is a massive problem in Australia because of how harsh the sun can be, especially in summer. So if you were reminded to put some screen on when it's, too bright or something, it could actually save lives potentially. This one is really cool because it's actually, so you have color changing textile, but it works with electrical current. So there's so it's textile augmented with thermochromic pigments, which means that when you apply a certain electric charge to it, it will change color. So I don't know if you really see on there, I have a video in my resources where you can see a lot better, but the textile can become some kind of screen based on the amount of current that you put through it. So I have no idea what I would do with this, but I would love to try and see how it actually works. One thing that is probably more accessible is stretchable textile, where you can actually get the value of the stretch. It's like, so that's available, you can buy it online, but it could be interesting for maybe athletes, being able to control or to check their performance based on how much they move, or even for your posture, if you wear a t-shirt and it sees that you start to kind of like bend and not have like a straight back, it could remind you like, hey, make sure that you sit straight. I've seen some devices that tell you, oh, wear that on your back, and it will tell you if you stretch or not. But I think what I like about textile is that you wouldn't have to add something rigid, like a Fitbit or something that is quite just not comfortable. It would be part of your clothes, and you wouldn't even think about it, but it would still be tracking what you do. And one thing that I saw just before I came here and I did it is that you can actually do some really, really cool stuff with stretchable textile and stretchable just textures in general. So I'm just going to show you quickly just a part of the video where you can see what they've been building. That's researchers again, but still.
We propose a glove for interactive hand pose capture. It's stretch sensing, fully soft, thin, easy to put on, and comfortable to wear. It can capture complex hand poses with high accuracy and at an interactive frame rate without requiring an external optical setup. Our glove successfully captures hand poses in situations where camera-based trackers fail. For example, when occlusion occurs due to object manipulations or body occlusion or self-occlusion or the hand moving out of field view. Also, changing light conditions or motion blur due to fast translational movement are challenging for camera-based systems, but not our sensor-based glove.
So again, I'm not going to play the whole thing, but I think that they really captured the real benefits of looking at interactive textiles. It's like it's really thin and flexible. You can really bend it in any direction and it won't really break, and you can really do pretty interesting stuff with it. Another thing that I would try to do is what is called electrical tomography, where instead of having conductive thread everywhere, you would actually add capacitive sensors all around a surface, and by checking the changes in capacitance in all sensors one after the other, you would actually have a pretty accurate X and Y position over a surface. So that is more of like a nerdy thing that I would love to be able to do. I don't really have any application for it right now, but it means that, yes, instead of having to put thread all over a surface, you would just have to add sensors all around and then use math to figure out the position of the finger. So you could kind of like recreate the trackpad pretty accurately, but on a piece of fabric. So I'm almost done. I'm a bit early, but so I have a few resources that I put together if you're interested. There's quite a few people actually doing projects like that. So there's a few tutorials as well, and I kind of wrote a blog post about my first experiments with it. I can share the slides later if you want, but some people are doing really pretty interesting stuff, way better than just my Spotify track thing. But yes, so basically that was it about textile interfaces. So, it's fine if you don't go home and start playing with that. My main goal was to make sure that it kind of makes more sense now that, how to build that type of stuff. And hopefully you kind of see the applications that could be done. A lot of the stuff I've been looking at have actually been in progress for a few years now. So people have been working on that for a few years, and even the Levi's jacket was actually available. I don't know if it's still available, but you can buy it online. So people are looking at embedding stuff into textile. But anyway, if you have any question, I'm here, or I'm on Twitter at devdevcharlie. I often, play with that kind of stuff. If you have any ideas that you would want me to build, I can do that too. But anyway, thank you very much.